Click for IB Biology. Our topic is solvation, the action of water acting as the solvent in biological situations, or solubility. You may prefer to think of this as looking at solubility. There's a blank PDF of this presentation down in the description, along with 10 questions with answers that you can use to check your progress. So this topic relates to the one covered in our videos on water, and the fact that water is a dipole molecule with a slightly positive charge on both hydrogens and a slightly negative charge on the oxygen. Now, when this comes into contact with, say, for instance, ions the size of a sodium ion, what happens is that the negative dipole here on the oxygen is attracted to the sodium, and the type of bonding that takes place here are weak intermolecular forces, which are called hydrogen bonds. Now, a hydrogen bond is itself about 1/20,000th the size of an ionic bond strength, but many of them can have important consequences in water, in biology. So in my image here, this is a sodium ion here, and the water molecules are attracted to the sodium at the inner area here, with the oxygens pointing towards the positively charged sodium. Now, in turn, what happens is an organization of the water molecules so that rather than moving around randomly, they become hydrogen bonded. Extended hydrogen bonding takes place between one water molecule and another. Let's just draw that out a little bit to show this. So this is attracted to the sodium, and then this is positive, this is negative, and in turn this forms a hydrogen bond with another water molecule. And so the water molecules become organized in these concentric circles of water molecules around the sodium ion. And of course, this is what we actually mean by solubility and dissolving. And so this becomes extended into this kind of diagram here, where the sodium ions are here with the water molecules arranged around them, like so. If we were to be looking at the solubility of sodium chloride, a simple salt in water, then we would also be able to look at the organization of the water molecules around the negatively charged chloride ion. But in this case, the water molecules would reverse their direction, with the hydrogens pointing towards the chloride, like so, and they would form a concentric circle around the chloride ion as well. So this is what solvation refers to. And indeed, the hydrogen bonding would become extended outward to other water molecules beyond, like so. And this is where we would get the additional concentric circles, as we saw for sodium, so it would happen for chloride ions. Now, an important feature of this to recognize is that because of the hydrogen bonding, when water molecules form solutions, the solvation and the solubility reduces the kinetic energy of the water molecules, so that with being involved in this hydrogen bonding means that they don't have the random movement anymore, or they have less of it, and so their kinetic energy has been reduced. This is an important concept for understanding other subjects such as osmosis. Now, the greater the concentration of the solute, the less the kinetic energy of the water molecules. It's like the total kinetic energy. So this is an important idea to focus on as we move forward, looking at the solubility of substances, the movement of water in cells. Link to the next video is showing a link to the channel and, of course, to the playlist.